Here we have a conservation of energy problem. A ball with a mass of 0.8 kilograms is thrown from the ground with an initial velocity of 22 meters per second. Calculate the maximum height of the ball. Assume no resistance. In order to do this, we're going to set up an initial energy and final energy equation. Now that we've done that, let's identify some of the things that we know. We know that the height initial is going to be 0 because it tells us that it was thrown from the ground. We know that the initial velocity is going to be 22 meters per second. We know that the height, we don't know the height final. That's what we're trying to find. And the velocity final we know will be 0 because when a ball is thrown up into the air at its maximum height, that's its turning point, so the ball for a split instant in time is going to stop. Using just this information now, we can eliminate some of the variables within our equation. If the initial height is 0, that means that the initial gravitational potential energy is also going to be 0. And if the final velocity is 0, the final kinetic energy is also going to be 0. So we can kind of simplify our equation, and now I'm going to rewrite it plugging in the different variables for kinetic energy and gravitational potential energy. Now that we've plugged in our variables, we notice that we have mass on both sides of the equation, and we're looking at the same object, which means it has the same mass. It's not changing in any way, so we can get rid of our variable for mass, which makes this equation even a little bit simpler. Ultimately, what we're trying to find here is the final height, or h sub f, and so we need to rearrange our equation. In order to do that, we're just going to divide both sides by g. I'll do that in a different color. Divided by g, so it'll cancel on the right, and we end up with a new equation. We have 1/2 the initial velocity squared divided by g equals our final height. At this point, we can plug and chug. We have 1/2 times 22 squared, and all of that is divided by 10. We can plug that into our calculator, and we will get a final answer of 24.2 meters. Now we have another conservation of energy equation. A rock with a mass of 2.4 kilograms is dropped off a bridge 38 meters tall. Calculate the final velocity of the rock when it lands on the ground. Assume no forms of resistance. Just like we did before, the first thing we're going to want to do is set up our total energy equation. Once we've done that, we're going to want to identify what we know and what we do not know. We know that the initial height, so hi, is 38 meters. And we know that the initial velocity is going to be 0 because it was dropped from rest. The height final we know to be 0 because that's going to be when it lands on the ground. We do not know the velocity final. That's what we're going to be trying to solve for. Using this information, we can go back to our equation and see if there's anything we can eliminate. If the initial velocity is 0 meters per second, that means that the initial kinetic energy is 0, and if the final height is 0, that means the final gravitational potential energy is 0. We have a simplified equation. Now we can plug in our variables. Just like before, we have mass on both sides of the equation, which means that our mass is going to cancel. We are trying to find the final velocity, so the first thing we need to do is multiply both sides by 2. When we do that, we're going to end up with 2 over 2, so this is 1/2 is going to cancel, and the 2 is going to cancel. That's going to bring our equation to 2gh sub I for initial height equals our v final squared. To get rid of the power of 2, or our square power, we're going to take the square root of both sides. When we do that, we can rewrite our equation now as the square root of 2gh sub I equals our v final. Now we can plug and chug. So we have the square root of 2 times 10 times our initial height, which was 38 meters. We will throw that into our calculator to get a final answer of 27.57 meters per second.